Hi friends, today many of you are on either a field trip or basically most of you are on a field trip. So here's the thing, you're still responsible for knowing this, you're still responsible for taking the notes, so I'm going to give you blank notes on Wednesday. I will also give you the homework so you can actually work ahead and have it done before the weekend if you wish. But I'm going to go through here and we're going to talk about two things today. We're going to talk about symmetry and all the different types of symmetry, and we're going to talk about tessellations, which is a fun thing that if we had tons of time in ideal geometry world, we'd actually have a tessellations project. But we don't have ideal tons and tons of time, and you guys know me. I'm not that touchy-feely of a teacher who does good with creative projects, but hopefully these will be helpful. So first of all, what is symmetry? Remember, we talked a little bit about symmetry before. We talked about reflectional symmetry, or known as line symmetry, and we've also talked about rotational symmetry. So we'll talk about those again and then more. Okay, and then more. So the first thing, when do we have symmetry? A figure has symmetry if there is a transformation of the figure such that the image coincides with the preimage. So if I change it, it looks exactly the same. A figure has what's called line symmetry or reflection symmetry if it can be reflected across a line so that the image coincides with the preimage. And remember, preimage is what you start with, image is what you end with. Now, example of this is a good old-fashioned heart. You know what I'm talking about? We had those when we were a little kid. If you fold that heart in half, you know it reflected on top of itself, and you get that perfect heart when you cut it out as a kid. That line that perfectly divides it in half into two congruent parts, remember, two congruent halves, is called the line of symmetry. And we talked about it the other day, but hopefully this will help you get your notation down. Line of symmetry. This is not writing well, so hopefully you can see a T-R-Y there. Symmetry, S-Y-M-M-E-T-R-Y. And it will always divide it in halves perfectly. Now, first of all, I want to know if this has line symmetry, and if so, it says copy the shape. So if so, let's put it this way, draw all the lines of symmetry. So on this first one, can I divide this in half and get symmetry? And a lot of you looked at that very quickly and said yes. Okay, now here's my question. How many? I'm sure a lot of you could see these two real fast. There's one. And lines of symmetry means there should be arrows, right guys? And you should go across this way. Everyone see those two? And then we have, how about going the same idea here? So I'm going to keep adding. So we're up to 2. This is going to be 3. We'll do the same thing here. So right away I got 4. Are there any other lines of symmetry? It's very easy to see those. And there should be a resounding yes. Look right here. What if I cut it in half going at this angle? There should be a quick yes. How about going at this angle, going across? Or even this angle. You guys see that we could still keep dividing it, and I have one more, a smaller one here. And you easily can see that I have 8 lines of symmetry. Now be careful not to double count. If you started counting, you go 1, 2, 3, 4, 5, 6, 7, 8. Don't count this one because you've already counted up here with 1. So that's 8 lines of symmetry. So no big deal. Now how about the next one? Are there any lines of symmetry for this triangle? And the answer is no. First of all, it's a scalene triangle. It's a right triangle. It's very hard to do. So this one would be no. All right, how about for the next one for C? Are there lines of symmetry? Yes. How many are there? Well, let's count again. Should we have to, remember we're supposed to draw all these. We have right in the center. I'm going to go crisscross first. My mind just went there. You can tell I'm tired tonight when I'm doing this. I literally want to go crisscross applesauce. Probably not the best I've ever used for examples, let me tell you. We got right down the middle here, and we got the ones going this way. There should be 4 if you did it right. Should be 4 lines of symmetry. How about this unique looking shape, this kind of banner shape, or kind of like almost 2 connected trapezoids? Yes, it also has some. It goes straight through the middle. You can see where it just flips over that line. So there's your other arrow. But could you also see it going through the middle here? Going across. I think you do. So let's keep trying the view. We have a few more I want to look at with this, and then we'll talk a little bit about rotational symmetry. So I think it's kind of cool to see this one. Okay, this is the typeset letter B. Looking at that, do you see any symmetry? Obviously, vertically, if I sit there and divide that, you can see that there is no symmetry. See that? But what if I go this way? Do I have any symmetry? Oh, look. If I can go smack dab in the middle there, I do have 1 line of symmetry. And it's in the middle. And so that's kind of one of those cool typeset type things that they do, trying to keep it to look pretty when they work with it. So that's a yes. Now, here's the one that fools a lot of people. I have 2 sets of notes. Okay, one set of notes says yes, one set of notes say no, and one says yes. Here's the deal. I'm going to say no, and this is me being a very particular person. The reason why I'm saying no is if I drew this where they said it looks like it would be, like smack dab in the middle here, I want you to look carefully at the stars. If I was to reflect this over, do the stars reflect onto themselves? And the answer is no for, guess what? 1, 2, 3 stars. And then the star right here. Otherwise, almost all of these reflect otherwise. So the answer is no because of line through stars. Now, if I was not looking at the little detail, it would be a yes. You could very see easily how that flag was formed. But those stars totally ruined it. All right, we're going to take a quick break and then